Hey everybody, so this is a quick demo video where I'm going to be walking through the use of one of these new Ethernet breakout boards. So to be clear, this is the old Ethernet breakout board we used, and maybe I should be more specific. This is a Ethernet breakout board, whereas these guys, these little guys right here, they're plugged in right now so you won't get too good of a look. You can see the silver versus the black there. These, the new ones, are RJ45 breakout boards. Now what's the difference? Well, Ethernet is a protocol or a type of communication that uses an RJ45, but it's for a specific type of electrical signal. And because of that, this guy has some electronics that are actually hidden inside this thing. That makes it, unfortunately, useless for us. So, congrats. These are yours now. Don't use them, but use them for anything else you want. So inside a Ethernet cable, you have 8 wires like this, or inside most of them, I should say. They're usually different colors, so you have an orange and an orange stripe, a green, if I can kind of lay this out here, a green and a green stripe, a blue and a blue stripe, and a brown and a brown stripe. So 8 wires total, 4 twisted pairs. So what we have going on here is we have 2 breakout boards of those RJ45s, and you can see they have 8. You can see the pins here. Let me get a little pointing tool here. All right, so the pins here are from the connector itself, and then there's just little copper traces that bring them out to header pins that we've soldered on for you guys. So you're accessing each of the 8 wires that are inside a standard Cat5e, Cat6, whatever you may choose, Ethernet cable. So what we have hooked up here in the background is a 32, 33, something along that line, foot Ethernet cable. It's pretty unwieldy, so it comes in here and then it's just skewed up behind the desk over there and then comes back in here. On one end, we have a Arduino Uno. This is a knockoff. Well, knockoff's kind of the wrong word. This is a third-party Uno made by the company Sunfounder, because the Arduino schematics are open source, so they put together their own little Arduino. So it's unfortunately a little lower quality, right? The pins here are a little looser and such, but it works for what we need it to do, and it shows up on the computer as an Arduino Uno. So we have the Arduino Uno. It's plugged into a desktop computer right now, so that's where it's getting 5 volts from through the USB-B port. And then on the other end of the Ethernet cable, again through another RJ45 jack, we have just a little demo board set up here. So I'll go through kind of a list of how I'm using all the wires, but we're using a breadboard. We've got a ground rail and a 5-volt rail, and then we've got 4 different demos. We are reading a potentiometer, we're reading a standard switch, we are writing an output to an LED using a resistor, right? So you can see here, potentiometer, 1 pins to 5 volts, 1 pins to ground. Pin to the Ethernet is reading the middle pin there, so the A0. For the button, we have one side of the button is to ground, and then the other side of the button is being read by the Arduino. We're combining that with input pull-up, which I'll talk about in a second. And then for the LED, if I can, let's see, knock it out of the way here a little bit. Maybe just, there we go. So for the LED, we have one side of the LED. Remember, these are direction specific. So we have the ground or negative side of the LED plugged into ground. We pass it through a little 1K resistor here, and then we have a output from a Arduino, again from the Arduino, which of course is through the RJ45 breakout board. And the final demo here, or the final demo using these wires, is a little joystick module. So if we look at the joystick module, we have, what's that, 5 pins defined for us. We have ground, 5 volts, VRX, VRY, so that is the analog reading, because if you look at it, it's really just 2 potentiometers there. You have VX and Y, and then a switch. And the switch is really, if you push down on this, you can see it's just like, it's almost like this little thing here. This is a big version of it, but it's just a little tactile switch, right? So you can push on it, even have a little reading there. So we are doing all that using just 8 wires provided by a RJ45 and an Ethernet. So to see how we're using that, let me go over to this little scratch pad here. So the RJ45 Breakout board, as we talked about, it has the female plug, right, where you plug in an Ethernet cable, and it really just breaks out the 8 connections into 8 different header pins. Now I started labeling them as little orange, little green, big green, and I got the order wrong because if you can look it up, there's actually a couple different Ethernet protocols. What really matters is if you have a standard Ethernet cable where the wire order on one end is equal to the wire order on the other, which is the end that the type of cable you're going to be getting at the final demo. All you have to do is make sure your order, if you got if your board is in this orientation, right, with the jack on one side and the header pins on the other, what's on this header pin is lined up with what you got on the other header pin on the other side of the Ethernet cable, right? So in this case, if you kind of follow my rows across here, on end 1, and this is the breadboard end, we're using 5 volts, ground, potentiometer reading, right? The switch, the switch reading, LED output VRX from the joystick, VRY of the joystick, and then switch of the joystick. And that lines up, of course, naturally with 5 volts from the Arduino, ground from the Arduino, analog 0 pin of the Arduino to read the potentiometer pin, digital pin 2 to read that switch, digital pin 3 to drive the LED. And what's nice about digital pin 3, I've copied over the tilde from the Arduino silkscreen. That means it's a PWM pin, which means instead of just writing either an on or an off state, we can use PWM, which of course is the pulse width modulation, which means over a very short duty cycle, say it's like this long, into like microseconds, something like that, we can rapidly turn the LED on and off, and we can vary the width of this on pulse with respect to the total time. So if I want it to look brighter, I can write on, right? And this is really going to look like just a constant voltage, but I'm just drawing that line for you. Or if I want it to look really dim, I can write just a really short on period. And so on and so forth. Or anywhere in between. So that's what a PWM pin gives us. So that's just a quick refresher there. For the 2 axes of the joystick, right, again into analog pins, because we're reading a spectrum of a voltage. We're not just reading a single state on or off. And then for the joystick switch, the switch built into the little joystick module, again, just into a normal joystick, into a normal digital input pin or output. The pins are synonymous. All right, with that in mind, I'm also recording my screen. So if I can get fancy and post, I'll be able to edit these 2 things together nicely. But what we've got going on the code, hopefully on the left side of your screen, if you see it, we've got a little Arduino script that I threw together, right? So I've defined some pin variables, and this should match up with what I had on paper there, right? So I've got pins defined for my potentiometer, my switch, my LED output, my 2 joystick axes, and my joystick switch. Additionally, I've got some pins defined for everything that I'm reading as an input, just so I have a quick way to capture it and then use that value later in code. So I've got the potentiometer value, the 2 joystick values, which again are really just potentiometers, the joystick switch value, and my other switch. And then finally, I've got a variable for my LED output. So we go into the setup of the script. I start up the serial monitor that you see running over here. And this is important. If you're using a digital pin on the Arduino, you have to define the pin mode, because these are very flexible pins, so you can use them as inputs or outputs, but you have to tell the Arduino so it knows how to configure it in the little microcontroller. So for the 2 switches, I'm using those as input pull-ups. And what that means is there's little resistors built into the silicon on the Arduino. And what that means is the input value of that pin is going to be tied through a resistor to 5 volts. So if I don't take that pin and the language is pull it to ground or connect it to ground, the Arduino will read it as 5 volts. And all that means is it gives you a nice stable way of seeing something is either high when you're not pushing the button, and then as soon as you push the button and you make a connection of that pin to ground, it snaps down to low, and you don't get these kind of floating voltages. And it's a nice little way of a built-in function of the Arduino and the ATmega 328 that gives you nice stable readings. If you just Google it, you'll find more information on it. And then you can also just give us a request through Edmodo, and I can talk more about that. And then finally, the last pin mode is that LED where I want to drive it as an output, so I define that there. All right, getting into the loop. So first I read all of my inputs, and I've got 3 analog inputs that I read with using the analog read, and I've got 2 digital reads where I use the digital read function. All right, and then I'm doing just a little bit of code here just to show something somewhat interesting in, on the board. I set the LED output variable as a map. So I'm saying, okay, whatever the joystick Y analog read value is, and that should vary from 0 to 1023, I want you to map that input, do a linear scale from 0 to 255, which is the upper bound of what you can do for an analog write, that PWM output. And I add another little wrinkle to it, and I say, okay, if the joystick switch val is 1, use the analog write, that PWM, vary the brightness of that LED on a scale, not just on or off. Otherwise, if the joystick button is pressed, just write the LED off. So that's just a little something so we can see something happening live on the other feed there. And then for just for reference for here, I am just printing out everything I'm reading in, as well as the LED output that I'm setting, which is what's happening over here. So let's stay on this view, so my editing's a little easier, and I'm just going to speak to it. So right now I'm moving that little blue potentiometer on the board, and indeed you can see potentiometer value is changing. Good. All the way up to 1023. Now this is interesting. So this can vary a little bit based on potentiometer. I did do a reading, and providing 5 volts at Arduino gets me 4.97 volts at the other end of the 30 feet of Ethernet cable. So we're getting a very low voltage drop across that long cable. And that's great, but it's also important to keep in mind that we're not really passing much current down the line, right? We're talking milliamps of current here. So we have very low losses. So that's good. So that's why I can get almost to 1023. I'm almost getting that full 5 volts. It flickers a little bit, but it's, for all intents and purposes, it's a 5 volt signal. And I come down and all the way down to 0 or 1. So that's good. Sweet. Now let's try the switch 1 button, which is over here. So right now, because of input pull-up, I am not making the connection on that input pin to ground. So the pull-up resistor that we've enabled is pulling it high, which reads as a 1. As soon as I push the button, oh, sorry, that's joystick switch. As soon as I push the button, it goes low or 0, right? And I can do the same thing with the joystick switch, right? So now it reads 0. All right, so what else we got? Okay, so we got the joystick XY, so I'm holding the little joystick module now, and let's see which one's which. So that's Y. So if I move Y left, I go to 0, right? If I move Y to the right, I increase. And you notice that when I let go, the springs hold it in a mid position. So that way you get a negative. You can treat the mid position as kind of your resting point or your 0. So if I go left, or maybe that's down, I go down towards 0. If I go up, I increase above the midpoint. If I let go, I snap back. And the same thing happens for the X, right? And this is where you can get fun. You can move both at the same time and just really screw with the formatting here. Okay, sweet. Finally, you may have seen this happening, but we have this little bit of code here where I am updating the LED. Well, I'm always writing LED out with respect to joystick Y value, so I've put them next to each other so we can watch that happen. What I write to the LED varies depending on that switch, but I always do this mapping. So if I play around with Y, we should see LED change. So right now, Y is in the middle, right, of its range of 0 to 1023, and therefore LED out is in the middle of its range of 0 to 255. If I bring Y down to 0, you can see joystick switch goes down to effectively 0, right? If I bring Y up to its max, LED goes to its max. So I'm getting a linear mapping. It's really the two ranges are just overlaid on one another, and they just have different slopes. That's one way to think about it. So anywhere in between, right, and it's pretty sensitive, I can vary that range of joystick Y, and therefore LED out. You can see that. Okay, let's go back to the live feed, and I'll show you that live. Okay, so we're back here. So again, looking at the live feed, all I was doing was moving this potentiometer a little bit, right? This was my pot valve, right? So that just goes either way. That's just a little breadboard potentiometer. This was the button, no big deal there. These were just two wires I was using to measure the voltage that was coming from the Arduino through the 30 feet of cable to make sure we were good. And let's watch this. So this is my Y axis. So if I vary this, we should see the LED change brightness. Again, that's the value of the PWM out. More bright. Less bright. Magical. Okay, and if I push the button, there's the logic saying turn off. Even if I'm halfway through, right? It just commands it. Cool. So you can do anything you wanted to with it. So this has been oh, and I guess I should say, right, here's the value of the RJ45 is it's all this in one little connector. So if I pull this guy out, right, one little Ethernet connector, 8 wires, doing all this. Now there's other things you can keep in mind if this is not enough for what you need to do for your kind of hoist control station. Let's say you want to do even more. There's some things you can look at. You might want to look at an I squared C or I2C type of connection, which uses 5 volts, ground, serial data, and serial clock. You might need pull-up resistors for this because you got a long wire run, but basically what this is this can support a whole bunch of different devices, such as little OLED screens, which I think we've used in previous years, IMUs, etc. And it's a 4-wire interface. Again, you're sharing a 5 volt and a ground, and then they can also share serial data and serial clock lines, as long as these devices have different addresses, which you can set up in just a little bit of research. But it gives you a whole more, a bigger set of capabilities rather than just a single LED with a wire, right? Now I can use 2 wires because you're already using 5 volts and ground, if you will. So now I can use just 2 wires and I get a whole little screen, right? And I can write text to that screen. So maybe that's more valuable to you than an LED, or maybe it's not necessary because you know, an LED is enough for what you need to do. Or, you know, maybe you don't need a joystick, or maybe you want to use a joystick, but you only want to use one axis. That's fine. Just don't connect the other guy, right? And use that pin for something else. Finally, let's say you really just want a lot more. Something you can look into is a MUX. And this is short for multiplexer. So you can get these very cheap. Do your research. Make sure you got a 5 volt or 3.3, and make sure you understand what you get, or ask questions to your mentor, or flow them back to us. But what the multiplexer does is it multiplies the number of pins you get. So basically, it's a combination of switches, and you specify to this little board what switch you want to activate, what switches, and it's binary, so it's got a power of 2 effect. And with those, you can actually increase the number of inputs you're getting in. I'm not going to draw a diagram because I'm probably going to mess it up, but check out multiplexers if you find you do need more inputs. It's maybe another $5 board you have to buy. It's more wiring. You should definitely draw that out and experiment with it before you commit to it. But if you find 8 wires is not enough, check this out. All right, thanks everybody, and good luck.